The topic of this video is long division. I'd like to show you a clever way of doing it using what we call a division table. This makes it very efficient, especially for large problems. It also makes it easy to understand, which makes the method worthwhile even for small problems. That's because there's no guessing, no backtracking, no mystery involved. We should say a few words about the definition of division. We define it in terms of multiplication. We say that 7,059 divided by 13 is equal to 543 if and only if 543 times 13 is equal to 7,059. In other words, we start with this number 7,059, divide by 13, and then multiply again by 13, we get back the number we started with. So if you know what multiplication is, you know what division is. That's basically all there is to it. Let's talk about some of the terminology and notation that people use for doing division. You can write the division problem with a slash like that. This reads as 7,059 over 13 equals 543. You can write it even more explicitly, one number over the other, like this. Again, that reads as 7,059 over 13 equals 543. You can also use the explicit divide by symbol. It looks like that. This reads as 7,059 divided by 13 equals 543. Last but not least, you can write it in this form, which is the way people do it when they're actually doing long division problems by hand. One additional bit of terminology, this guy here is called the divisor. That's Latin for the thing doing the dividing. The answer up here is called the quotient. That's Latin for how many. That comes from the expression, how many times does 13 go into 7,059? And the answer is it goes in 543 times. The guy in here is called the dividend. That's Latin for the thing being divided. One thing to watch out for is the financial community uses the word dividend in a completely backwards and confusing way. The financial dividend is actually the quotient. It's what you get after things are divided up. So that's what the financial community would call the dividend. But in mathematics, we stick with the original meaning. A dividend is the thing being divided. Suppose we have the following long division problem. I suggest the first thing you should do is make yourself a division table. You've probably heard of a multiplication table. A division table looks pretty much the same. So let's start by doing this. We're going to do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's all very quick and easy to do. And now we can write down the corresponding multiples of 13. 1 times 13 is 13. Twice that is 26. Next one is 39. Next one is 52. You know that from playing cards. Next one is 65. Notice that you can do these by successive addition. Just add 13 to the guy above it. So it's very, very quick and efficient. So the next one here is going to be 78. And then the next one is 91. And then you get 104. And the next one is 117. Now, if you add 13 to that, you get 130. And that's a valuable check because we have other ways of knowing that 10 times 13 is 130. So that tells us we haven't accumulated any errors as we went down making this little multiplication table. Now, you call it a multiplication table if you read it left to right. If you start from here and go to there, it's a multiplication. If you go here to here, you're multiplying by 13. We're not going to do that. We're going to do it the other way around. We're going to read this table right to left. So 26 divided by 13 is 2. 78 divided by 13 is 6. So that's what makes it a division table instead of a multiplication table, is we're going to read it backwards. So we're going to need somewhere between 2 and 9 of the rows in this table. We don't know which ones. And you can construct this so quickly, it's easier to just construct it than to figure out whether you need it or not. Now that we have our handy table, let's use it to actually carry out the multiplication. The general idea is we're going to proceed left to right along the dividend here, subtracting things. And we want to subtract something that's as big as possible, but not too big. So if we start with a 7 here, there's none of these numbers we can subtract that makes any sense. So we could write a 0 on top of the 7, but we don't have to. So let's move on to the next digit here and see what we can subtract, considering these digits 2 at a time. Well, 78 would be too big, but 65 is not too big, so we got to put a 5 here as part of the answer. 5 times 13 is 65, and we line that up like that. That's short for 6,500, but we don't need to write the zeros. We can just do the subtraction, bring down the 2. 5 from 5 is 0. 6 from 7 is 1. And that completes that step of the calculation. We now move on to the next digit here and say, well, what can we subtract from 102? Well, 104 would be too big, but 91 looks like he's as big as we can without being too big. So let's subtract 91 from this. You can bring down the 7. 1 from 2 is 1. We get 117. Oh, and don't forget the answer, the quotient here. So 7 times 13 is 91. Do the subtraction, we get that. Now, we move on to the next stage of the calculation. What is there we can subtract from 117? Well, got a big winner there. We can subtract 9 times 13 from that. 9 times 13 is 117. That gives us 0, and that is the remainder. So that's good. We don't have a remainder in this case. So anyway, that's the whole deal. 13 goes into 7,527 exactly 579 times. You can also do a check here that this is a 3-digit number multiplied by 13. We get a 4-digit number. 500 times 13 is, going to be about the right answer. So it's all very plausible. So that's the trick for doing long division efficiently. Construct a division table. It looks a whole lot like a multiplication table, except you read it right to left instead of left to right. The table is very easy to construct, and having one speed things up quite a bit. Also, it's helpful conceptually because it removes a lot of the guesswork and removes a lot of the mystery.